Martin Sabarsky from Solana is here, CEO, and he's going to show you some of his products. All right, thanks, Martin.
Thank you, good afternoon. Happy to be here. Thanks to Barbara and Steve and the entire F3 team for the opportunity. And I have brought samples. This is 1 kilo of the roughly 25,000 kilos of photosynthetic microalgae that my company Solana has grown over the years using its technology. I'll talk a little bit about that, but more about where we are from a commercial development standpoint, and more importantly, what we need to do to get from where we are to that promised land. Before I begin, though, a little brief introductory remark about myself. This year I will officially, I think, be 2 decades, 20 years in the industrial biotech sector. I've spent the last 11 of those years with Solana, and the past 8 of those as CEO. And I have the honor, I guess, of representing a company that is one of the veterans in this industry. Although I realize to my chagrin only now that I should have retitled this talk, Farming the Future of Fish-Free Feed, but I wasn't convinced I could actually pronounce it correctly. But so in your minds, think of that, because it really is going to be, we think, part of the solution, but I agree with other speakers that algae, microalgae, heterotrophic algae, photosynthetic algae, insect protein, bacterial protein, these are all going to be part of a mosaic of solutions that need to be brought to bear if we're going to tackle some of these global challenges. But hopefully we'll be hearing a lot more about Solana and other algae companies that are at this conference, if they're not presenting, because we have come a long way in a relatively short period of time. Let's see if I can advance. Thanks, guys. So who is Solana? What do we do? If I can turn slightly over here, what we focus on is photosynthetic microalgae that are non-GMO. We have nothing against GMO, but we prefer to sort of work towards the lowest common denominator because we do have global aspirations for nutritional products, which means typically staying clear from GMO until the regulatory and marketing environment is more receptive to it. We focus on the power of the sun, and until politicians figure out how to tax it, it's currently free. And that gives us a certain advantage both in terms of cost, principally, as well as sustainability, we think. From a production standpoint, our main inputs are traditional agricultural inputs. So you can think of fertilizer to grow the proteins. You need nitrogen and phosphorus, but we're looking and have developed strains and processes around conventional ag inputs, so very compatible with existing infrastructure and supply chains that are well developed for agriculture. And then we do need concentrated CO2, which we can choose either bottled or waste flue gas, as other speakers have pointed out, depending on how cheap the process needs to be and how big a scale it is and how available the CO2 is. Our claim to fame from a technology standpoint is reflected in some of the patents below, but it's basically using a combination of photobioreactors and open ponds and used in concert. So we have culture that's kept clean, the strain or strains that we want to grow that we keep in photobioreactors operated at industrial scale, and it's only the last several doublings that are done in an open pond. So a continuous batch hybrid process is what our IP platform mainly covers, as well as, of course, our proprietary strains. For the last 7+ years, we focused on high omega-3 producers, principally EPA omega-3 as the highest value omega-3 on the planet. But as we see here from a representative compositional shot, most of the biomass is in fact not omega-3 or even oil, but is other stuff like the proteins and the sugars and other micronutrients and some ash. But once you have this feedstock, you can plug into existing off-the-shelf fractionation technologies to then pull out different products. And so what we do have is a multi-product biorefinery model, and we've principally focused on the genus Nanochloropsis, a known omega-3 producer that makes this liquid gold EPA omega-3 that we and others are targeting as the basis for commercialization. Why do we do that? Because a small amount of omega-3 can produce a lot of value in the near term. But as we see here, of course, the majority of what the product is on a fractionation basis is not omega-3 and not oil. We have leveraged this particular model and the data behind the growing of the feedstock to sign what I still believe is the world's largest contract for algae-based crude oil, but as a byproduct or certainly low-value co-product to this type of a model. And we brought on board a Thai Union as a non-exclusive feed partner, but I'd like to add other partners on the feed side and the food side. And so for those of you in the room who are in this business, we are open for bringing on other strategic partners and financial partners as we look to scale. So a couple slides on sustainability, and this may be duplicative with other slides, but we think it's important to focus not just on carbon footprint, but perhaps even more importantly on fresh water and arable land footprint. And there's simply not enough arable land and fresh water available to feed 10 billion people enough protein based on existing crop or animal sources. And so this is where insects, bacteria, algae, single-cell protein, we need it all. But what we see here, especially when you're doing a recycle of CO2, you can have an order of magnitude improvement on existing protein or ag production. There's also, as we're talking with Thai Union, an opportunity to help improve the sustainability of shrimp and fish farming by taking their waste and using that as inputs, as many in the room are looking to do in a variety of ways, so-called trash to cash. And we're certainly open to that, although we don't need the low-cost inputs to be able to make our model work. One of the key aspects that at Solana we've leveraged and others in the single-cell protein or microalgae space are the very high yields that can be generated using a photosynthetic process, similar for heterotrophic, but this just shows kind of a range of different types of yields versus other photosynthetic types of crops that have been successfully commercialized for a variety of different applications. And this just looks at the oil content, the starch content, energy content, and protein content, but this compares very favorably to, again, existing protein and other nutrition sources in the supply chains today. So as far as Solana and our lead commercial strain of Nanochloropsis, right here, Ka32, we've grown it at multi-ton scale over many years, not just in our now former R&D facility in Hawaii, but also through government grant-funded programs at a variety of other locations throughout the United States, including in California, in Arizona, Florida, and Georgia. And what I'm reporting here are average growth rates that were achieved at all the sites, and in some cases, significantly higher peak yields are achieved. We focus on the average because that's what's clearly in our financial model. We're very proud that about 2 years ago, in a publication from the Department of Energy, which in the US is the lead agency funding photosynthetic algae production, that our lead strain, this guy right here, Ka32 Nanochloropsis, was one of the 2 strains selected to be the state of technology for 2016 that will be the benchmark by which further progress towards the 2020 biomass yield growth rates are measured. I'm also happy that C046 is also another Solana strain. So our 2 lead pre-commercial but late-stage development strains are well represented here as one of the leading sets of microalgae for US production. We are looking to do this globally, though, not just in the US. We've done a lot of feed trials with partners. Much of it was grant supported, and not just in the US, but in Norway for salmon and carp, in Thailand for shrimp, in New York for pigs and chicken. Most of the data is published, and without question, each one of the trials has been varying degrees of successful. Most of these have been published again, so you can read it for yourself. I'm happy to give you my slides. But we focus mainly on aquaculture because of the fact that it is the most valuable meat that you can point to for these types of applications. Here's some photographs from the first trial we did with Thai Union in 2015-16, and you can see enhanced pigmentation at relatively significant inclusion rates, up to 15% in the case of one of the shrimps that's listed there. And we're very pleased that Thai Union, I can say now, has finished the second and larger trial with our Nanochloropsis algae meal, so the leftover after omega-3 extraction. And what they like about it is not just its performance, but as an adjunct to omega-3 production for a nutraceutical application, we can price the product at somewhere between soy meal on the low end and fish meal on the high end based on the performance of the feed product. So what do the economics look like? And I admire the previous speaker or speakers who did give some numbers here. What this requires for commercialization today at existing yields and small commercial scale on paper is something that's north of $10 a kilo of revenue. And that's an important metric, but we see this as a way station until you can get something like $4 a kilo of combined revenue for the high protein meal and lower value oils that Nestle and other feedstock purchasers of crude oils would want to buy. You can't get there right now. You're underwater, cannot make that up on volume, but with Nanochloropsis and perhaps a select few other microalgae that can be commercialized, you can start driving up the yields, lowering costs over time through learning curves and at scale, and if the price of protein as reflected in fish meal only doubles, so we're talking 2x, you can envision a situation in the not too distant future when you're at this type of a scenario where you only need the two commodity products to be able to generate something like a 50% margin. That's something that can scale to very high volumes. And that's what we're looking to do. So in the US, we've now sold our R&D facility. We're post-R&D pre-commercial, and we're looking to upscale on-site, utilizing the same strain, same sunlight, same seawater, and basically the same land that is available next to our now former facility owned by our next-door neighbor, Cyanotech. And what is shown here is that this can be highly profitable, even at small scale, while we continue to improve the yields and the cost structure so we can get to really agricultural scale. We need some help. Thank you in advance for your questions and for your assistance in helping us get there.